So having been in this game for a couple of years now, I will say, and being in machine learning and AI for longer, 99% of the challenge is just trying to figure out what the person wants. Yeah. So are you saying like, yeah, how many times it does it? Yes. And so a lot of what is the work that's going on now by a lot of the top model companies is trying to identify dynamic ways to put the appropriate amount of thought in so that it doesn't spend 10 minutes trying to figure out how to add 1+1, but it does use that if it's trying to achieve the right amount of legal reasoning. And there's some controls over that. If you're using these reasoning models, you can sort of dial up or down the effort that they use to try and get to the answer that you're looking for.
Anything else on the lexicon while we're here? So I sound smart for the next year.
We got through agents. We got through reasoning models. I'll put one more out there, and this one's a slightly weirder one. We haven't got weird enough. This one's called NoLiMa. NoLiMa. Okay. NoLiMa. This is a result from Adobe Research. I want to say the paper came out this year.
Okay.
And this was a test of the capabilities of large language models as they put more and more and more things into them.
And so it went over the course of an hour with our catch-up conversation with Dr. Aron Ahmadia, who is the head of applied science at Relativity. You know, I knew things had been evolving pretty rapidly in the generative AI space, but I thought I had done a reasonable job of keeping up with things, at least in the legal technology part of that space. But the answer is, I don't think so. Folks, if we have not yet had a chance to meet, my name is Chad Roberts with eDiscovery Co-Counsel. We're a law firm that helps plaintiffs' lawyers with electronic discovery and complex litigation. This has become a series of in-depth conversations with people who are at the cutting edge of the most recent legal technologies. It started in earnest with a conversation with Dr. David Lewis just about 3 years ago now, and then another long talk with Dr. Ahmadia during Legal Week of 2024. So far this year being 2025, we have 3 more conversations like this in the pipeline. This is the first. The other 2 will be Tara Emery and then Dr. Jeremy Pickens. More about that later. But this is the first, and it's a catch-up call with Aron about an eventful past year for him with a rollout of a new platform and technology that he's been deeply involved with, and the observations that he's made, the lessons that he's learned, and what's next on the event horizon for this technology, and most importantly, what do lawyers need to know about it. These are long conversations, unapologetically long conversation, and it because most of the conferences that we go to could not support a format like this, I think it would miss the audience. These are really meant for folks who would like to soak up every bit of a subject matter at another level of detail. And there may not be that many of you out there, which is totally okay. You know who you are. And by the way, the 3 articles that Dr. Ahmadia mentions in his talk with us, the 3 research articles, there are links to those articles in the description below, just below the window for this. Thanks for visiting with us. It's always, we enjoy helping people get access to this kind of content. It's really important. And here's our catch-up conversation with Dr. Aron Ahmadia about what the last year has been for him and what the next cool new things are on the horizon and what lawyers need to know about it. Here's our visit with him.
I'm Dr. Aron Ahmadia. I'm the head of applied science at Relativity. Happy to be here today. So when we chatted last in 2024, it was still cold. Yeah. It was still Legal Week. Yeah. I think I was in a t-shirt.
Yeah.
But I thought I'd come back a little bit better this year. And AI has gotten a little bit better this year as well.
It's a theme.
So Relativity last year had just launched the LGA of Air for Review just a couple of months prior, January 1. And so we had just seen the first sort of commercial production usage of the tool for discovery. Since then, we've run millions of documents through Air for Review. We've handled over 100 matters. We've got dozens and dozens of customers using the tool. I'm extremely proud of it. It moved from a limited general availability release in January to a full commercial release in September with Relativity Fest. And not only is it available in the US, it's available around the world, where we have access to Microsoft Azure OpenAI capabilities. So that's the US, UK, Canada, Europe, Australia. And that's awesome, not just to offer Air for Review within the US, but also offer Air for Review around the world. We have another special announcement this week. Air for Review is now available in FedRAMP.
That's
If you are a federal agency and you would like to use Air for Review for litigation or a FOIA request or some other matter, Air for Review is now available to you.
It's great.
In Relativity for Gov. And so it's an exciting, been an exciting year. It's not just Air for Review. We've also had the GA release of Air for Privilege. So sort of, we didn't stop at the transformation of relevance review. We wanted to go after all of first pass review. So after you found the relevant documents and you want to start protecting the ones that should be withheld, we've got a solution for that as well. Air for Privilege helps you identify the privileged documents and withhold them, automatic privilege logging, and other features as well, leveraging some of the AI technology that we acquired from TextIQ, and as well as the marriage of generative AI technologies and the tools that we developed in Air for Review. So I'll start first with the scholarly or academic publication. That paper is called Beyond the Bar, and it's an academic measurement of the capability of GPT-4 using a prompt that we had designed to work with document review. And we were able to sort of statistically measure. We actually had run it over a number of different use cases, but we only ended up going to, let's say, publication with one, partially because we wanted to do one that was extremely rigorous. And so this was done with Dr. Jeremy Pickens and Dr. Dave Lewis now at Elevate. And I believe Dave is at Next Point now.
Yes.
I got that right. Okay. And so I would be remiss if I didn't mention that Tara Emery, Lenora Gray, and Kristen Traylor were all involved in analyzing and understanding those results. And again, what we found in that study was that Air for Review can identify more responsive documents than human reviewers. That one was a particularly surprising case. We found that human review had missed almost half the docs that Air for Review found. Air for Review was a little less precise, but we did find that Air for Review was helping the senior attorneys spot documents that the contract attorneys had missed on their first pass.
So maybe recall was a little better.
Recall was substantially better. It was over 90%, and the contract attorneys, I think, had barely hit 50% in that situation. And again, I think that we sort of have this fallacy in our heads that any system is infallible. It doesn't make mistakes, and it doesn't need to be validated, whether it's keyword search or human attorneys or TAR. And it turns out that we put generative AI review up to the highest standards. And so typically when we do a comparison between generative AI and any of these other systems, we find that generative AI outperforms cost, efficiency, accuracy. It's right now we believe that it is the best technology and the best approach for document review. Coming back to your question about what we do, and it's like a little secret sauce.
Yeah.
It's not secret sauce. I'm happy to talk about it. And we'll come back to this topic because it's a fun topic.
Okay.
In 2021, Google released a paper that talked about how large language model performance improved when the model was asked to show its work and to think about what it's doing. So when we first designed Air for Review, we thought that we would make the model more effective by asking it to show its work. And we thought, well, what would be a good way for a model to show its work that it was identifying responsive documents? Well, like, okay, first, find some parts of the text that could be responsive and just provide those to us. And then we said, after that, explain why that might be responsive, but stop, because it's possible that you're sort of not taking something into account. So then argue against yourself about why that may not be responsive, what you might be missing, or some other thing that could cause you to be wrong about your current assessment. And then after you've done those things, then make your decision about whether each document is responsive or not. And so what we were following at the time is the approach that Google had called chain of thought. I labeled it chain of evidence. Nobody at Relativity liked that, so I didn't get that one through.
Okay.
But it is a form of chain of thought. It increases a few things. First, when the model uses chain of thought, it gets better results. It's more accurate. And that makes sense a little bit, right? Sort of guiding the model to, let's say, think in a particular way. But the second thing that was unexpected to us, but very obvious in hindsight, was that attorneys loved it, right? Oh, the model is saying that this document is responsive. That's because it found this text over here. This is its argument for why this is responsive. But the model doesn't stop there. It's like, here's the information that would change my mind or that you were ambiguous about in your instructions to me. And so all of those things together, they become part of the output of the model. And if you're using Relativity 1 and you've used Air for Review, you have access to those. And you have the full power of relativity while you're using that. So you can search the rationales, you can search the considerations, and sophisticated attorneys will use those to go even deeper into the merits of their case or find adjustments that they need to make in their instructions to get the model to behave the way they want.
Neat.
Yeah, it's a little bit of a surprise, but a very positive one. It's been very well received. And we use that same chain of reasoning to power some of our other products like Air for Privilege and Air for Case Strategy. It's a good question. And we're going to get a little bit weird here.
Let's.
Okay. These large language models, they are systems very unlike anything else we've ever built before as humans. And that's because they were not constructed. I'm going to take part here and I'm going to glue it to part here, and then I can analyze it and I can understand what it's going to do in the system. They're much more akin to having been grown in the lab.
Okay.
Which is to say, we have this very large, complicated thing. It's got millions of parameters to it, or billions of parameters, or even hundreds of billions of parameters. And we know how it was grown, but we don't actually know exactly how it behaves. And we're still learning things about the large LLMs as we go. And so one of the first things we learned was that using chain of thought makes them more accurate. And it also forces the model to down a particular reasoning path that allows you to look back and say, well, when the model made this citation, when it made this description to me of why it made this decision, I know why this document is or is not responsive according to this model. Now, what's funny is if you had asked the model for that information in a different order, then you wouldn't have gotten an explanation of the model for what its thinking was. Because let's suppose I asked the model whether a document was responsive or not first. Then if I ask it for a citation, it's looking for a citation to justify the answer it just gave,
right,
not reasoning about the responsiveness of the document based on the citation, based on the considerations, based on the rationale, etc. And again, where this is really important is if you are worried about hallucinations.
Yes.
So if you are concerned that the model might, because these models make mistakes, the model might make something up, then you would be very curious, or you'd want to know for certain that when the model gave you a citation, that came from the actual text of the document that it was analyzing. And it turns out the last thing that you want to ask to verify that the citation is real is the large language model itself. So what we do is we have large language model generate the citation, generate its considerations, generate its rationale, generate the final call. And then we actually stop the large language model and we take a look at the result from outside. And there is a separate system that verifies that the citation is real before that result gets passed up to the user.
Wow. Your description of that caused me to have one other thought, which is the challenge of the 75 item request for production, and everybody's trying to do a first pass review on 75 different prompts. Let's not call it a prompt yet, but and those 75 different subjects could be wildly disparate in terms of their coherence, of conceptual coherence. And how's the model handling that? Are you still throwing? Is it still a safe workflow to throw all 75 topics at it at once, or does performance improve or diminish based on whether they're bite-sized, coherent chunks of?
Yeah, it's a good question. So as one of the tests for Air for Review last year, and I'm going to call these tests because the official support in our product is up to 10 issues now. But I have seen roughly 20 to 40 issues tackled in the system. First, we usually recommend that people break those down into no more than 15 to 20 issues. And again, we've done some experiments just to see how far we could push the system. It's a challenge.
Okay.
And so there are various ways to tackle this particular one. We're certainly working on ways to increase the number of issues that can simultaneously be considered. But I would definitely be remiss if I said that asking the model to consider more things does not decrease its performance. Now, does it decrease it by 1%, 5%, 10%? It depends on so many other factors. But we do know that the more things you ask the model to try and do at the same time, the more it's trying to sort of keep track of, a 50-page document that's highly technical versus a 5-page lightly worded email. The complexity challenges the model.
So all other things being equal, a user should try to tend toward coherence in terms of the subject matter if you're worrying about the accuracy of an algorithm.
I think that it's a great question, and it's one that we're continuing to spend a lot of time on in 2025. If you're in the business of trying to get a review done for production, you really want to focus on, is this document relevant to the matter or not? And in the simplest possible language, taking that information and putting it together. Right? What are the things that would make this document responsive?
All right. Anything else about review that in the past year, other than, we can read the literature and we've benefited from that, but let's do the horizon for review right now. Where do you see the material things on the horizon for review?
Yeah, we're seeing a bunch of developments. We'll see within. So now I'm going to speak generally, and I'm not going to make any sort of statements about Relativity's product line.
Sure.
But I'll tell you about what the models can do and what sort of natural, obvious developments we should expect to see. So the first obvious development we should expect to see is that these models can now operate over more than text. They can operate over images. They can operate over video. They can operate over audio recordings. And so as more types of evidence enter for review for production, we'll see these models start to shoulder some of that load as well. And they'll be able to review images. They'll be able to help review audio. And that's kind of the first place to start, is that we'll start seeing review of non-text sources.
Yeah. Let's do priv.
Yeah.
How goes it?
Privilege is going extremely well. And I think the feature that, again, we don't always know what people are going to be the most delighted by. But if I, based on my description of privilege just now, what was the feature that stood out to you?
That it generated the log automatically.
Yes.
And hopefully this would be the brass ring, was able to craft a non-privileged description of what made the document privileged.
Yes. And you really put not just a brass ring, but a gold ring on it.
Okay.
And again, this is the difference, I think, sometimes between the applied scientists and the lawyers who are in the trenches and come up and say, please,
this is
this is killing us.
Right. This is killing us.
If I have to write another priv log, and I mean, I think that this is certainly the bane of many discovery attorneys today is managing these, and they get very big, and you want to write them correctly.
Yeah.
And so we have found that by working carefully with our customers, understanding how they write privilege logs, the different formats they like to use, how to summarize a document without putting in the things that are necessary and ensuring that the things that aren't are not. Also using language that is extremely precise and curated to the needs of that log. That's something that we focus on as well. And so it's something we're paying a lot of attention to, and people have been very delighted by.
And it's working out.
That's working out very well.
Fun.
More to come in every dimension, every facet.
Right.
The models get about 10 times as powerful every year, and they've followed that trend for the last 2 years. And that's a very staggering number to think of. If you think about how Moore's Law worked, Moore's Law said that the CPUs went twice as fast every 18 to 24 months. I'm telling you that the large language models are going 10 times as faster every year. It is a massive, massive compression. It's as if we have seen a decade of semiconductor development in a year. Look, you and I are gentlemen of a certain age.
Yes.
We remember when this was happening with computers.
Right.
And you had a Pentium 1 or, a 486 and you had 100 megahertz. Now remember how cool it was to go from 100 megahertz to 133 to 166 to 200, right? But what if you had gone from a 100 megahertz CPU to a 1 gigahertz CPU in a year? It's a very different game. And then the next year, it got 10 times faster.
Okay.
So there are a number of different factors at play. First of all, Moore's Law, that the semiconductor density continues to double, or sort of the density of well, my brain is falling over, but the density of the semiconductors in lithography is doubling every 18 to 24 months, leading to these. This is alive and well.
Yeah.
So all the way at the very bottom of the hardware level, we're still seeing that doubling every 18 to 24 months.
Okay.
And then one level up from that, you have the large language models themselves, and they're becoming more efficient.
Oh.
And then in addition to the large language models becoming sort of nimbler, smaller, more efficient, you have the services on top of them, and those are becoming more efficient. So if I'm a commercial service provider like Microsoft Azure, I'm in the business of serving GPUs as efficiently as possible. So any efficiencies that improve from the service provider are passed on to us. So we're getting the level all the way at the hardware level from providers like NVIDIA. We're getting it from the model provider, like the builders of the models like OpenAI and Anthropic. And then from the hyperscalers like Microsoft Azure that are hosting these models themselves. All three layers become more efficient together. That's creating the 10x. Again, there's competitive market pressure as well. There's not just Microsoft serving. There's not just OpenAI building models. Now, NVIDIA is kind of the only one building GPUs that are used at scale, but there are even competitors there. And so we're seeing that emerge, and we're seeing pressures kind of at all levels, and the competition at all levels leading to benefits for us. Yeah, and efficiencies. Yeah. It's going to penetrate every aspect and facet of the practice of law in the next 10 years, and some, I think, much sooner than others. At the end of the day, lawyers like to know a lot.
Yeah.
Their business is knowledge.
In a hurry, too.
Their business is knowledge, and large language models are excellent at retrieving knowledge, at helping to reason now through that knowledge, gathering facts, curating facts. And so, again, we think about how lawyers will become more enabled. Um, the difference between sort of the eras of pre-ChatGPT and post-ChatGPT, very similar to the eras before great search engines and post-great search engines. And if you think about how transformational it has been for attorneys to have access to the law and to be able to search and do their own legal research, I think we're going to see similar developments around all facets and aspects of data that an attorney uses to help manage risk. And so, or whatever it is that they are practicing, whether they're on the transactional side, whether they are on the litigation side, every aspect or facet of what an attorney does is about, in some sense, getting closer to technology and understanding more of the data and more of the opportunity, and organizing that information in a way that's useful for them and their clients.
The last time we visited, we talked about risks, and that kind of risk where you don't know what you don't know for lawyers.
Sure.
And you were helpful to give advice of here are the things you need to worry about.
Yeah.
And to be careful about, and to make sure that your vendor's thinking about.
Yeah.
In the year that's transpired, have you seen that shape evolve, or the scope of those kinds of risks evolve, or would you describe them any differently than where we were about a year ago?
I think that this is going to be very interesting because there are evolving risks, and they sort of come up in every sort of way. Like, let's start with the bread and butter of discovery. How is AI affecting discovery? Well, it turns out that if you're in the business of producing information that might be relevant to a case, and now all of your clients' meetings are recorded and automatically transcribed, and there might be a transcription error, but the recording is gone, and you just have a transcript where somebody says something very clearly that they eat marshmallows for breakfast every morning. Is that a transcription error? Or did they indeed say that in the meeting? Did you capture it? Did you get the right speaker? And so one of the first things is just going to be around preservation, collection of evidence, how people are interacting with chatbots. Is that being stored? What can be retained? So just all of the sort of first basic pieces of discovery are going to need to be considered in light of the sort of the emerging, I don't want to say an explosion, but an emerging great deal of data that's now going to be created that's new and of a different type. And if modern data was hard, if RSMF and text messages were hard, well, generative AI discovery is going to be its own fun game, and transcribed audio is going to be another one that will be quite the challenge.
So new information sources on the horizon for us to
new information sources on the horizon. And while we're on that path, if you think about somebody's mobile device, if you think about the various things that they're using, like Slack, to communicate, now they're going to be talking to ChatGPT, or they're going to be talking to Google or Anthropic. What are your enterprise policies around that? Have you set yourself up for success around the use of generative AI? When you have a very appealing nuisance, I think the word is, for somebody to use, whether it's ChatGPT, and they really want to use it, how are you setting your company up for success so that they're using it safely and you're correctly using any data that's going into it?
I am.
So confidentiality, privacy, security, collection, preservation, all of those will continue to become more important. They're going to require a lot of thought and a lot of teamwork between the legal team, IT, the other business units that are interested in, for example, taking advantage of this information and these technologies.
Usually in the life cycle that I've experienced in the decade or so has been cool new thing comes out, the people that are building the cool new thing are all about the functionality of the cool new thing. And they're not necessarily all about the information governance challenge, being able to search, retrieve, and extract the problems that come 5 years later when the general counsel says we have to do this. And then technology kind of chases it again. A different pack of hounds, technology hounds, chase the new technology. And it sounds like we may be on the cusp of that kind of life cycle repeating itself for these products if it hasn't started already.
I think for a lot of the larger products, they're already aware of these concerns as they enter enterprise environments. And so you do see that they do offer collection mechanisms, preservation mechanisms. We have integrations from Relativity into several large AI providers. And so that's important. And I don't want to say it's table stakes, but it's something definitely that you want to make sure you're considering. So I don't think that we're necessarily going to stumble into the discovery, but I think some people will. And they will realize after the fact that there was a lot of information that was moving around the organization that they were advising that they did not properly protect.
Many years ago, 2 or 3, on a lightning round.
It's been 100. It's 100x 2 years ago.
It is 100x, but in at a time long ago and far away, you were on a lightning round, and everybody said, go down the line and say, what do lawyers need to know? And everybody was talking about all this, stuff. And you said statistics and and then that was it.
I got into trouble for saying that.
Did you really?
Yes,
Why?
I did.
Why?
Well, I think there were some attorneys in the audience who didn't appreciate that I implied that maybe they did not have the firmest grasp on statistics. As part of that, I know where I was.
I'll say it. So and that was a lot of was like, man, what was he talking about? What does that mean? And some of it was about validation.
Yes.
The sense was you now need to learn how to validate.
Yeah.
And have you seen? And then what the consensus is that the principles and fundamentals of validation are, in the generalized sense, agnostic to whatever tools and methods and processes you use to get your output and to discriminate between two different groups. That in a generalized sense, the validation process is independent of that. And so quit worrying about all these different tools and whether you understand them or not. But you ought to think about shoring up your validation skills, because there's a little bit of statistics stirred into that. And so what people are saying now, and I'm just curious if you agree with it, is that in a generalized sense, do we need to do anything different about validation that we've done before? I mean, do you still think the proposition stands that, random sampling of a nose set and all those things? Is there anything better? Does it remain the case that that's still the test at the end of the day?
So Chad, the very first thing that I want to tell you,
yes,
is that validation is not required in every situation. Just where you want to make sure that you use the AI responsibly, and you probably in a situation where you used it at scale. There are going to be situations where validation is not needed, but where it is needed, 100%. Everything that we learned, everything that we struggled through with the TAR validation, TAR 1, TAR 2, whether you use a control set, whether you use some other technique, if you're using an illusion sample, all of these techniques still apply. And so one thing that I want to make sure I'm very clear on, though, is that we know that there are going to be places where people use generative AI where they don't want to use up validation, and that's okay. Now, if their adversary suggests that they use validation. Well, then that's a different conversation, and maybe it's negotiated into the ASI protocol. But sometimes you're going to be in a situation where validation doesn't make sense or it's not needed, and that's okay too. However, we've gone, how far into this conversation are we? We haven't used the word agents. We haven't said agentic. Once. Do we want to go there?
I want to say agentic because I was on a conference call this past month.
Yeah.
And anybody that didn't know what agentic meant felt pretty left out.
Okay. Should we start with the definition of an agent? So the problem, first of all, with agentic is it's very similar to AI in that agentic is the stuff everybody else is doing that you're not doing yet, right? That's the starting definition of agentic. We can narrow it down a little bit more. Typically, one of the definitions that people like to use is there is a planning phase, and the agent is allowed to execute against that plan and then make decisions based on what it's sort of evaluating or seeing in an autonomous way, some semi-autonomous or fully autonomous way. And that's another definition of agency. There's another one from the great folks at Hugging Face, including Margaret Mitchell, and they define agency based on how much decision making the agent has over the level of code, for example, that it's using. So if the agent is sort of just on a very strict path, and then input goes in and output comes out, that's a very, very low level of agency. If it's allowed to choose door A or door B, that's a slightly higher level of agency. If it's in some kind of loop where it gets to decide when it's done or it quits, now we're getting even higher. And then there's sort of the triple X. And again, when it's in a loop, maybe it has access to some types of functions or APIs that it can call. And by that time, you've got a system that's very capable. But let's say the scariest system is when the agent is given a computer and it's given let's say a interpreter, and then it's allowed to write its own code and execute that code. And that's sort of the highest level of agent autonomy. Not only is it sort of given, as much time as it wants, sort of given resources. And so, whether your definition is, can you schedule and plan, whether it's how much function calling you get to do versus do you get to operate in a loop, at the broadest scale, the way that I think about agents is the same way I think about AI. How much control or how much risk do I give this thing, or am I allowing this thing to create, and how much value is it creating for me? It comes down fundamentally to what are the things it's going to try and do, and what are the risks, and what level of supervision do I have over the decision making that it's taking.
So how do you see that playing out into our space? Do you see it designing workflows? Do you see it?
So 2 years ago, when we first started seeing, the real release of these large language models and how they were going to start affecting us, I said, probably the biggest amount of agency that we will see in the next couple of years is automated first pass review, where I give the model some instructions and then it goes and reviews a bunch of docs for me. I better go build that system first.
Right.
I better be the one who's built that system. Yes. Because first of all, it's the largest scale that we can sort of imagine. First pass doc review is the largest scale. So we wanted to make sure we could get that right. We've got great validation mechanisms in place because the industry had already put them together.
Right.
So if you think about an agentic system, first pass review, error for review is an agentic system because it makes decision making at scale. The humans don't go through and review every single decision. We statistically sample to get comfortable and provide the level of oversight we need. So the very first thing to say is, well, agentic AI has actually been here for a while. The rest of the world is catching up to what the legal technology industry has been doing for the last 2 years. And so we're here on agentic AI. We're going to be leading in some sense, which is a fun place to be.
Yep.
Now, on the planning, on the scheduling, you'll hear people talk about sort of dynamically using different large language models. I see two systems that people are going to be very interested in the future. The first will be conversational systems, where an attorney or a user is trying to communicate their intent or their requirement to a computer system. And that will now sort of be done through agents instead of the other interfaces we've had in the past, whether those interfaces were, mouse clicks or writing a configuration file or writing a program. More and more of those requirements will now happen in sort of natural language.
So do you see a world where I could bundle up all of my forensic collections?
Yeah.
And instead of telling the project manager what to do, like, hey, on the cell phone collections, I need this date range, these custodians, and these conversations in 24-hour chunks. Emails, just do regular old family production with emails, or just family review of emails. And then on these other goofball information sources, I'd like this, I'd like that. These are the date ranges. And then I'd like to have it reviewed for this criteria of responsiveness or non-responsiveness. And then you could just hit the button and go.
I believe that the project manager will still be there. You will communicate your requirements to the project manager, and the project manager will relay your instructions to the system and then supervise it. Because it's not yet in the realm of possibility that you are going to want to supervise the system. You want to just hand it off. Yeah. I could tell by the way that you were talking about it that you didn't want to be involved in the details. And as somebody who doesn't want to be involved in the details, you need to find somebody who is and is willing to supervise the system.
Gotcha.
And so that person, I think, is going to have a much more interesting, fun job than probably they've had in the past.
Maybe less tedious.
Less tedious. I think it's gonna be more engaging. It's gonna be more interactive. The model is gonna be doing more of the non-fun stuff for that person. But I don't think that somebody who is interested in dumping their needs into a system is gonna have them met without human supervision of the system's tasks, responsibilities, questions it has to ask. Did you mean October 2024? Did you mean October 2023?
Right.
These documents don't have a date. What do you want me to do with them?
All of those fun questions.
So I think that it'll be easier. It's going to be more automated, and there will be more agency, but there will remain human supervision that will be adequate and proportional to the agency and autonomy of the system.
So I cut you off with my
it's fine.
Agency thing. What agency concepts do you think are more likely to be actionable and marketable in the horizon?
I mean, aside from first pass review, I think that the one that everybody's probably talking about the most, has generated a ton of buzz, is deep research. And there are a couple of these projects floating around. Is this the first time you've heard the word deep research? Okay. For those of you, deep research is the very first time you've heard of it. There was a conversation not too long after the models were released that said, wouldn't it be great if, first of all, I was wealthy enough that I could have just one of these models continuously at my service, where I asked a question and the model went out and it started searching the web to try and answer that question. And it didn't stop until it had generated a 50 to 60 page report answering the question for me. And the first proofs of concept of this were not actually done by OpenAI. They were actually done by a couple of different open source projects. And then eventually Google Research released one in, I think around December last year. And OpenAI released their own version, I believe, somewhere in the beginning of the first quarter. And so there's been a lot of excitement about this. I would say it's still kind of it's prototypes in terms of how well these systems work, but they indeed go through, they sort of clarify what you're looking for in sort of a first pass. And then they'll go out and they'll typically search as many as 50 or 60 sources of information. They'll pull that information in, they'll compile it, and then they'll turn it into a cited report.
Lawyers would love that.
I think for some use cases where you need to do a public search on what information is available today, sure, I think they're going to be using it right away. There's some interesting challenges around, for example, privacy, security, and confidentiality that they're going to need to verify with whoever is providing the tool to them. When you think about how web searches work, some of the information that you are requesting is being conveyed out to a search engine.
Yeah.
And so you have to think through who's going to be providing that service for you.
I know this may initially sound a little circular, but could you conceive of some kind of segregated system or agent that did the validation of another larger, like first pass review, right? In other words, could you see a reliable model of not having the same model check it so it work? It's already decided what it thinks the right answer is, so it's not going to change. But could you see some of that validation itself being addressed in some way by these models and the things that they can do?
So having been in this game for a couple of years now, I will say, and being in machine learning and AI for longer, 99% of the challenge is just trying to figure out what the person wants. And so a automated validation can only go so far as understanding what the nuances of a particular. It's the same limitation. Now, we're going to be able to solve those problems in a variety of ways to ensure that let's say the friction or the distance between the model's understanding of the person's intention and the person's intention are as close as possible. Then we think about just effectively the alignment problem. But yeah, I think the capabilities of the models are growing, and it's very impressive. We will continue to focus on ensuring that they are aligned to the needs and requests of the user.
For someone, just last question for last topic, unless there's one. Have we missed one? Have we talked about any things like have new things come into the lexicon like agentic and deep research? Any of those other things like that need to come into the lexicon of a person who fancies themselves as being?
We should talk a little bit about reasoning models.
Talk to me.
I'm talking to you. So Chad, in your sort of research into AI, have you come across the S1 paper on simple test time scaling?
No.
I don't often recommend academic papers for a variety of reasons. Sometimes they're very dry or they're hard to pick apart. But this one I think is worth reading. S1.
How would I identify it? S1?
Simple test time scaling. Oh my God, could I name the authors? I couldn't. But if you have
test time scaling,
yeah, and S1 will help you find it. And remember, these models are getting more powerful and more powerful and more powerful. And so, as part of the increase in performance, we've also had access to, let's say, a cheaper class of models that are fairly capable. And so one of the questions has been, how would you increase the efficiencies of these models and make them even smarter than they are now? So let's take the most powerful model available today, like a GPT-4 Omni.
Okay.
How would you make it even more capable? So remember that large language models are autoregressive. When was the last time we talked about autoregressive, Chad?
It's been a while.
Okay. So autoregressive means that the model treats its output as input the next time it generates something. So if it starts a sentence with, my dog went outside, when it generates its next token, it knows that the dog is outside. So if you modify the model's output or the input, you can trick the model into thinking that it's already thought something or said something, right? And again, it's not necessarily a trick. but you're guiding the model to behave in a certain way. This is exactly how chain of thought works.
Yeah.
Chain of thought says, I'm going to look at a citation, I'm going to generate it. Now, when the model makes its next explanation or analysis, it's doing it with the citation in mind. This autoregressive property is actually quite important. We bring it up a lot. So because models are autoregressive, there are some things that you can do to kind of steer them into particularly interesting ways of behaving. So let's suppose that I didn't want a model to just display a little bit of chain of thought. I wanted it to display a lot of chain of thought.
Of its own chain of thought, or
to continue reasoning.
Okay.
So first I could say, hey, model, I want you to think a lot about this problem before you give me the answer.
Yeah.
But there's another technique. You could say, hey, model, I want you to start thinking. And the way that you're going to start thinking is you're going to say, thinking starts. And when you're done, I want you to say, thinking stops. Okay? You're with me so far? All right, I'm going to ask you a math question, model. Okay, what's 1 plus 1? All right, and model's like, well, 1 and 1 together are 2. And then it says thinking stops. And again, okay, like let's do a harder problem. You know, what are the prime roots of these 3 things? Or what do these 7 words have in common? You can see the model thinking about it, putting the pairs together, trying something. And it's at some point, it gives up and it says thinking stops. But if you're in control of the model's GPU, and so it's just output that text, you could stop the GPU and say, we're going to remove that last line of text where you said thinking stops, and we're going to replace it with the words, oh, wait. And then we're going to restart you. And the model now, after it's done all of its thinking, suddenly encounters, oh, wait. And then it realizes that it didn't do a complete analysis, and then it goes back and it does some more. And it turns out that this simple trick, which is at the center of this reasoning paper, allows you to take a high school level model in terms of the AIME math exam and have it achieve something in sort of like the top 75, 80% at the college or graduate level.
Sounds like kneading bread.
Maybe kneading bread, but
like folding it over and doing it again, and then folding it over and doing
it's a little bit like folding it over and doing it again. But generally, when you knead bread, you don't turn a high school class athlete into a collegiate Olympiad math winner.
Gotcha.
And so I mean, it is really very unexpected. I don't think that anybody really saw this. And again, when people talked about the strawberry model last year and O1 and reasoning, and there was all that hype about it, it was effectively just the unveiling of this.
But do these just take longer? I mean, are they?
They take longer.
Yes.
They cost more.
Yes. Okay.
But
they'll get there.
But these models are already very fast.
Yeah.
And they're already not that expensive. So it is now it's an interesting trade-off where I can spend more money, then now it's test time as opposed to build time, more money to get a smarter answer out of them.
And can you throttle the iterations of O8? Like the O8?
Yeah, O1. Yeah. So are you saying like, how many times it does it? Yes. And so a lot of what is the work that's going on now by a lot of the top model companies is trying to identify dynamic ways to put the appropriate amount of thought in so that it doesn't spend 10 minutes trying to figure out how to add 1 plus 1, but it does use that if it's trying to achieve the right amount of legal reasoning. And there's some controls over that. If you're using these reasoning models, you can sort of dial up or down the effort that they use to try and get to the answer that you're looking for.
And what kinds of use cases can you see for the legal application of that?
Well, how often do you ask an attorney to think for more than a second before they give you an answer?
You would hope they would.
So we're going to see these models permeate every place where decision making or analysis or thinking occurs. It is. If the 4.0 model is good enough, then you don't need to switch to a reasoning model. But every time a slight increase in performance or accuracy matters, then you're going to use that model when you're willing to pay for it.
It's a way for a less sophisticated model to hack its way into more sophisticated.
It is where all of the smartest models, they will get there by using this trick.
Wow. I can be an Olympic athlete too.
Yeah.
My brain.
That's,
That's fascinating. Okay. Anything else on the lexicon while we're here? So
No.
I sound smart for the next year.
We got through agents. We got through reasoning models. I'll put one more
Right.
out there, and this one's a slightly weirder one. We haven't got weird enough. This one's called NoLiMa. NoLiMa.
Okay.
NoLiMa. This is a result from Adobe Research. I want to say the paper came out this year.
Okay.
And this was a test of the capabilities of large language models as they put more and more and more things into them. Right. So typically, the way that you would evaluate how good a large language model was, let's say over 100 pages, is you would hide a needle in the haystack. So you got 100 pages. I'm looking for examples of harassment. I'm going to put something very, me somewhere in those 100 pages. NoLiMa says, well, what if it's more subtle, right? What if it's spread out across, two different places in the text, and I've got to read those together to figure out how, if harassment happened. Turns out that most of the large language models on the market today don't do so well in the NoLiMa benchmark past 25% of their context window. So if the context window of the model is advertised as 100 pages, performance might start dropping off at 25% or 50%. So 25 pages or 50 pages. And every model has a slightly different context window where they start to perform worse, and it depends on the task. So I think the most important thing to take away from something like NoLiMa is that just because a task fits in a model's context window does not mean it's appropriate for the model to handle. And the model might need the task broken up more before it does the task well.
I get you.
I think a lot of attorneys have seen like larger context windows as panacea. If I just throw the 10,000 documents in and I say, hey, find me the 5 documents or do this analysis for me, I don't think that large context windows are going to solve a lot of.
You'll pay a price for that.
I mean, right now, the larger context windows don't necessarily solve the problem of the model, let's say, kind of thinking well. And so on one hand, the models are getting smarter. On one hand, and they're getting more powerful. On one hand, we're able to reason with them and they generate more. But on the third hand, they're still limited in what they can do. And they're not sort of these silver bullets that can solve every problem if you just throw all the text in. And so we're still seeing them fall over in tasks as they try and get larger and larger context windows.
New last topic.
All right. New last topic. Final topic.
This is,
For real.
Oh. For real now. Thank you. Bonus round. Yeah, you're answering the question right there.
I don't know if there is an answer. I think that there are going to be people emerging who will specialize in educating and counseling,
being the explainers.
Yeah, and I think that we will probably see some type of cross-discipline emerge that is a more formal study and more formal education for what these systems can do and how to reason about them and how to think about them. It is any book that has been written is, I don't want to say out of date in 3 months, but I gave you academic research papers that crossed my desk in the last 3 to 6 months.
Right.
And so that's just how fast everything is moving. And so I think that continuing to fall back on principled approaches, knowing what systems you're using, understanding how they were built, how they were tested, and what purposes they were built for and how they were tested against them is going to continue to remain very important.
Still, can we have mTOR out there in legal vendor land?
A little bit of caveat emptor, but also having the skills that you need as a statistician or as a procurer of technology. That same skepticism I still want people to have going into 2025. And again, the excitement is going to be overbearing. I think we're going to have another year of hype just as big as 2023, where people are going to be tremendously excited about reasoning and about agents and about the legal research capabilities and automated doc review and all of these things. And so we're just going to have to be calm and excited, but also prudent.
Buckle up. Buckle up.
Buckle up. Yeah. Buckle your seatbelt.
Thanks so much. We've imposed on an hour of your time at Legal Week, which is a huge thing, and and Relativity as well. And as fast as things evolve, we'll keep chasing you for updates.
Thanks, Chad.
Thanks
Looking
so
forward
much.
to the next one.
Appreciate it.